Okay, hello everybody, welcome to physics this morning. We're going to talk about our assignment, practice 2C and 2D. The first question here is a car accelerates uniformly from rest to a speed of 23.7 kilometers per hour in 6.5 seconds. So what I always do is put my numbers into, meters, seconds. So how do we do this? Well, if you have 23.7 kilometers for every 1 hour, that's what this is, right? So we have to factor out these labels. So in the end, we want to have meters over seconds. Do you agree with that? Okay, so how do you do that? Well, you can pick on either label at a time, it doesn't matter. But just like any other math thing, if I put kilometers on the bottom here, that's going to cancel all the kilometers down to 1, right? Okay, do you agree? So 1 kilometer is 1,000 meters. Okay, so this is factoring out that label. Now I have meters on top. Do you agree with that? Okay, so then the next label that I have to factor out is hours here. So hours has to be on top, right? Hour. 1 hour is 3,600 seconds. Okay, so now we factored out that label because hours divided by hours is 1. Now what we're left with in the end is meters per second. Now we can do the math. Okay, so how do we do the math? Okay, so you go to your first number and type it in. 23.7. And you go to your next factor over here. And this is the number that you're going to be putting in, right? So that's in the multiplication part. So you put 23.7 multiply or times 1,000. Push equals. So I push equals every time. It works on every calculator. And then you go to your next factor. That's on the bottom. Because you multiply by 1, it's going to be the same. So now you divide by 3,600. Do you agree? Okay. So that's divided by 3,600 equals 6.5833 meters per second. Okay. So that's 6.583 meters per second. Okay, now, if you look, now factor labeling is something you need to be able to do for a lot of classes. If you look at this right here, you can just look at the factor as this, right? 1,000 over 3,600, which is equal to 1 over 3.6. So, anytime you want to change from kilometers per hour to meters per second, you can divide by 3.6. And that should give you the same answer. Okay, so... What the heck happened there? Okay, so that was a little pause for you to get your little bits of homework done. We're talking about number 3. I'm not necessarily gonna do this one, but I'm gonna show you specifically what you need to have in order to get help from me. Okay, so the first thing is somewhere you have to have your formulas, which is velocity. Average velocity is total displacement per time, or you can say x minus x sub naught divided by t. That formula you have to have written somewhere on your paper so you can refer to it. The other average velocity formula is v plus v sub naught divided by t. You have to have that written so you can look at the variables and see what you're working with. And then the new formula is acceleration is v minus v sub naught divided by t. So I'm not going to help you if you don't have these readily available written somewhere on your piece of paper or on a note card or something. The second piece of information that you have to have in order for me to help you is your variable list. So the variables are v sub naught, v, acceleration, displacement, and time. So this variable list will be something you will be working with for the next 2 months. Okay, and the reason why you need to do this is so you do a lot of subconscious stuff. But to get, somehow you got to get your subconscious brain to work with your conscious. Well, this is one way to do it. That's by this visual aid. Okay, so look at I'm gonna do a jet plane lands with, I'm just gonna say, a different number, 550 meters per second. Can accelerate at a maximum rate of, let's say, 10 meters per second squared. Okay. Can this plane land in, let's say, 10 kilometers? Okay. So, do we have a question? That's why I like doing live video lessons, because I always screw up. This second formula should be over 2. Thank you very much. And that is circumstantial if the acceleration is constant. So just to reiterate, I changed this here. Average velocity is v plus v sub naught divided by 2. Okay, so what is your v sub naught in this new question? Yes, for this new question, the initial velocity is 550 meters per second, which is really, really fast. And what is your final velocity then? Yeah, your final velocity is right here, rest. So you want this thing to come to a rest, so you have to know rest is 0 meters per second. So it's 0 meters per second. What's your acceleration? Yes, negative 10 meters per second every second. What's your displacement? So there are a number of ways to do this, but really we're trying to figure out if this is going to be enough space or distance for this thing to slow down. So we're going to just figure out how much distance we need in order for this thing to happen with these variables. Okay? The other way we could do it is put in 10 here, 10 here, and then figure out what the acceleration is. But we already have an acceleration. So I think the fastest way is just going to be figuring out this displacement. Okay, so now you need to look at your formulas and look at what you have, okay? So really what we're going for here is this, right? Because we have a velocity equals displacement per time, average velocity, or our displacement is time times average velocity. You agree with that? So if you look at this, we kind of hit a hard spot because we could have an average velocity, right? Because we see that these are 2 velocities here. So we can right away say that our average velocity is going to be, using this formula, is going to be 550 divided by 2. That's our average velocity. Do you agree? So now we're left over here with time, but we don't have time. So what I need to do is find another situation that'll give us a time with the variables that we have. Which formula do you think would work here? Acceleration, right? Because we have acceleration, we have these 2 velocities. Now we just have to use this formula, solve for time. Okay, so I'll do that right over here. Acceleration is v minus v sub naught divided by t. Multiply both sides by t. Divide both sides by a then. So time is equal to v minus v sub naught divided by a. Do you agree with that? Can you do that algebra? Because I don't want you to be memorizing that formula. Do you have any question on what I do with the algebra? Okay, so now we could either solve for this and then put t in, or we could put this in, right in there, and then solve for it all. It's up to you. I guess in this case I'm going to solve for myself. So t equals 550 minus 0 divided by 10 equals 55 seconds. Okay, so now I can put that in there. Okay, so x then equals 5,500 times 55, all divided by 2, And our displacement that this plane needs to land then would be, so the answer then becomes 15,125 meters. Okay, so if I go back to my question, I had 10 kilometers, which this is 15 kilometers. Can the plane land? The answer is no, because it needs a displacement of 15.125 kilometers. I only have 10 kilometers for a runway. So the whole question is, how do you know that we're supposed to do all this stuff? So that's why it's so important to have these formulas written on your piece of paper and this checklist. Because what you do then is you find a formula that has your answer in it. So we're looking for x, right? So I go over here to all these formulas. Which one has x in it? Well, there's really only one that does, and it's this, right? This is the only one that has displacement in it. So that's why I started with that formula. So I took this formula down here, and I solved for x. So I got x by itself. And then I said, oh, what do I need to find x? Well, I need time, and I need average velocity. So now that I have my formula in a manner that shows me the variables I'm going to need to figure out the rest of the problem, well, then this directs me to the next formula or the next part of the solution. Okay, so we're going to do another sample problem here. We're going to try to change some of change part of the question here so I don't do your homework. Okay, so here's a little modified version of the question. Now, notice, did I put any signs in there? Not really, but is there anything that signifies direction in here? The arrows, right? So at this point, I want to put in signs. Well, this problem says that the initial velocity is negative, so that means I'm going to have to say that this direction here is negative. So to the right is negative. Okay? So then by default, 180 degrees different is positive. So we're going to call this positive. Okay? So the formulas that we have to work with are on your piece of paper. This is the checklist all the time. We have oops. There it is. Okay, we have v sub naught, v, acceleration, time, displacement. Okay, so in this case, we're looking for v here, right? So I'm just going to go somehow signify that's the one I'm looking for. Okay. My initial velocity in this case is negative 20 meters per second. My acceleration is a positive 5 meters per second squared, and I have time, 0.5 seconds. Okay, so if I look at my formulas here, I have average velocity is v plus v sub naught divided by 2. I have average velocity is displacement per time. I have acceleration is v plus, v minus v sub naught divided by time. Thank you very much, Martine. Okay, so I need to find v somewhere. So I look for the formulas that have v in them. Well, I see it here. I see it here. Okay. Now, the other thing I have to do next then is look at the formulas and see what else I have. So do I have average velocity? Well, no I don't. So I'm probably not going to use that formula. There's no v in this one, so I'm not using that. So this is kind of where I default to. So I'm looking, do I have acceleration? Yes. Do I have v sub naught? Yes. Do I have time? Yes. So this is the formula. So acceleration is v minus v sub naught divided by t. You can plug and chug here if you want, but I'd rather that you get used to doing the algebra with the variables. So I'm looking for v, so I'm going to solve for v, multiply both sides by t. okay, and then add v sub naught. So v equals v sub naught plus at, which just happens to be one of our what I call mother formulas, because a lot of things come from this formula. Okay, so now that we have that, you can just plug and chug. Our initial velocity was negative 20 meters per second plus our acceleration times time is 5 times 0.5. Okay, so it's 5 times 0.5. Our final velocity then is negative 17.5 meters per second. If I did my math right, please check that. So it looks like we did the math correctly. Let's just add on to this and find the displacement, because now we have our v here. Okay, so we go back to our table and we can fill in some more numbers. Our final v was negative 17.5. Okay, so now if we want to find our displacement, we can look at our formulas. Okay, displacement is right here, right? So we're going to start with that. Average velocity is displacement per time. Solve for x. If you do your physics homework, then you x out the TV, which means you don't sit there and watch TV all night. Our time is 0.5 seconds. Our average velocity can be described as this. So we can just substitute that in right away. And we see that it's negative 20 plus negative 17.5, all divided by 2. If you put all that into your calculator, you should get about 9, right? Okay, so the calculator says negative 9.3, oops, negative 9.375 meters. And I missed the negative over here. And the negative is important because it shows the direction. So I went into the negative direction, 9.375, during that time of acceleration. Hopefully that helps you guys. Have a good day. Have a good day.